Here we go, another explanation of the math problems that you should be working on with projectile motion. These ones were a little bit more complicated, and as you'll see with a couple of the ones that I picked, how they're solved is actually the same way. Okay, let's get started. So, Jack be nimble, Jack be quick. Jack jumped over a candlestick with a velocity of 5 meters per second and an angle of 30 degrees to the horizontal. Did Jack burn his feet on the candle? Well, that's kind of a little bit of the nursery rhyme. However, and we can add it to some of the physics that we're looking at. Some of the things that we know, again, is the fact that Jack jumped with a velocity of 5 meters per second, and that the angle that he jumped at was 30. So what we need to find out that he also, I guess we also jumped over his candlestick here. So let's draw the candlestick and this little flame. And so did he get over it, as it would be looked at, is that height of the candlestick is 0.25 meters. Did he get over that? And so we would have to determine its height. We have a height, but that's not the height that we can use. We can't actually use that height. Instead, we need to do a hypothetical problem where we don't know the height. And so we need to solve and do a few other things. And so what we also then need to know and understand, again, just like always, there is gravity present, and that A, it's not a very good A, that A is the same as gravity, which in case is, again, negative 10 meters per second squared. So if we use that, we should also then be able to find, another way to think about it would be at that velocity and angle, how high of a jump did he actually get? And if it was shorter than 0.25, then yes, he would burn his feet. If it's greater than 0.25, then no, he would not burn his feet. And so that's where it's really more down to a yes or no question. And so we can solve for that, though. There is something that we should understand, and that is at the top of there, we should have only velocity in the x direction, and therefore the velocity in the y direction is going to equal 0 at the top there. Only the horizontal is going to have a value. And we don't need to know anything about that. And so what we need to know is at what point, what is the height at that point? That's what we're solving for. We can find our initial velocity here and utilize that as our final velocity in the y. So we can utilize some things that we know. And so we have those two parts, and it's utilizing an equation that we haven't used a lot or lately, and that is the v sub f squared is equal to v sub I squared plus 2a, and I'm going to change I think in our equation sheet it says an xf minus I. I'm just going to change that. I'm just going to say that it's h, because that's what we're solving for, the height. And I'm going to change this a here. I'm going to make that a g, because that's really what we're looking at as well. And so now I can actually solve some of this stuff. Well, to solve for my initial velocity, I actually need to use the equation that velocity yi is equal to the initial velocity, and that's going to be my 5, times the sine, because that's going to give me the up and down, that's going to give me that opposite, because sine of my theta. So I'm going to actually put everything in here and say 5 times the sine of 30 is actually going to give me a velocity of 2.5 meters per second. Now again, over on this other equation, I can put that in there of 2.5. I'm going to square that. I can put 2 times gravity, and it's actually gravity's, remember, is a negative 10 actually. It's a negative 10. I'm going to multiply that by h, because that's ultimately what I want. I'll change the color here. By h, and that's going to equal the final velocity, which again is going to be 0 squared. Well, 0 squared is just that, 0. And then 2.5 squared is 6.25 minus 10h. I need to put my 6.25 onto the other side because I'm going to eventually want to solve for h. So I'm going to get a negative 6.25 is equal to negative 10h. Then I'm going to solve for h by dividing by 10, both sides by that. Now a negative divided by a negative does cancel those out, so leaving me with the fact that Jack jumped with and got a height of 0.31 meters. So he jumped with had much greater height than the 0.25 of that on the candle. And so does he burn his feet? No, he does not burn his feet. All right, Superman is said to leap tall buildings in a single bound. And this is actually Superman from the Golden Comics. Superman of the more current is always flying, so it doesn't always work so the same. So how high is the building could Superman jump over if he were to leave the ground with a speed of 60 meters per second and an angle of 75 degrees to the horizontal? Well, we know some things, and the first is that he again has a velocity of 60 meters per second, and the fact that his angle is 75 degrees. Now, we're looking at finding out what is the height of that building that he can jump over with that, with those parameters involved. Again, because we're on Earth, and so is Superman, otherwise he wouldn't probably be able to do that. I believe they didn't have that ability on Krypton. And therefore, it would be a negative 10 meters per second squared. That's pretty constant. And if Superman is going to jump over that, he would have follow the same type of thing, in that at the top of his peak of his jump, his velocity in the y direction would be 0. So velocity in the y is also going to be 0 at that point that we see there. We don't know yet what the velocity in the y direction is initially, but if we find it, we should know what it is, utilizing what we know. So we use, again, the same equation that we have been using, or did use on the previous problem, that the velocity squared is equal to the initial velocity squared, and these are all in the y, plus 2, I'm going to write g and h right off the bat, since we know we have to use them. Going to solve using the sine theta times the initial to give me the velocity in the y initial. Our numbers here are going to be much larger. Well, that's also because my angle is much larger as well, and we are dealing with some big numbers of velocity as well. So with that, you'd see that our velocity is very close to 60, which is, again, it's almost 90, so it's almost going to have that same exact, and that the initial y velocity is about 57.96 meters per second. Now the velocity over final velocity is going to be 0, and we're going to square that, is equal to the velocity of, I'm going to put it in parentheses because of the decimal, 0.96, squaring that, 2 times a negative 10, I'm going to say is a negative 20 times h. We're going to see that that is 0. This becomes a very large number, somewhere around 3,358 or 59, and then minus a 20 times h to get 20, or the h by itself. I need to subtract both sides by the negative 359, and that would equal negative 20 times h. I need to divide both sides by a negative 20 for those to cancel out. Negative 20. The negatives cancel out when the division happens, and my h now becomes approximately 168 meters is how tall of a building that would be. Now, that roughly it's a pretty big story building. I think you would roughly be able to multiply that by 3, and you're looking at around 400 feet, probably close, a minimum 400 feet high, 10 feet per building, so it'd be about a 40-story building, if not more. Again, we're just rough guesstimation with that. But our final answer would be 168 meters is how high Superman can go. Now, hopefully you rework this and utilizing kind of what you've learned and get a better score.